IoT Unplugged, where we talk to industry leaders, innovators, and major players in the Internet of Things, bringing you the best and latest insights. Tune in to learn more. In this episode, I speak to Satyajit Sinha, Principal Analyst at IoT Analytics, as he takes me through the evolution of Edge AI from tiny ML to multimodal VLMs, as well as discussing the different types of edge and important use cases. Hi Satya, thank you so much for joining me today on the IoT Unplugged podcast.
Thank you for inviting me.
Could you start by introducing yourself, talking a little bit about who you are, where you're coming from?
Hi, my name is Satyajit Sinha. Feel free to call me Satya. I'm an principal analyst at IoT Analytics. I have been working in IoT market research industry more than 12 years now. Been with IoT Analytics 5 years almost, and focused on hardware, connectivity, compute, edge AI, security, automotive as well.
And for those listening, could you also introduce IoT Analytics?
IoT Analytics is a market intelligence firm. We provide market intelligence to IoT community, and now we are expanding to more than IoT. We are looking into AI and topics like generative AI, data centers, automotive. Industrial manufacturing is something in our core of the company, so we look into that, and we have a different way of interacting with the industry. Products like reports, trackers, surveys, and other products that we have.
Yeah, I mean, you mentioned all really important topics in the context of IoT and connectivity. One that we're going to delve into further today is Edge AI. I don't think it's a technology you can probably escape mention of. So it would just be interesting to hear from you in your position, looking at the market day to day, what you've observed in terms of adoption of Edge AI.
I mean, before we go there, I think it's important to first very clearly clarify what is Edge AI. I think AI, we all know, and it has been there for years now. It is not the chat GPT moment happened with the world. Before that, IoT was already dealing with AI, but the AI was happening generally in the cloud because of the scalability issues and everything and the cost perspective. It makes sense to compute AI inferences in the cloud. However, now what is happening is that this AI is coming into the edge. And when we say edge, it is the location of computing which is closer to the sensor data or sensor generation. Now it can be vary from device to device. It is not just one device. It can be your sensor camera, which has a sensing capability and a computing capability within the device itself. It can be your gateway. It can be which collects all the sensors information from multiple end nodes or multiple micro edge AI to one place, and we call it thin edge. And it can be IPC, it can be gateway, it can be router. And then you have thick edge, which is more like in-house edge servers, from the company like HP, Lenovo. They produce edge racks, and you have a very high power computing capabilities in there. So there are three different layers of it. And when we say where is the adoption happening, I'm gonna go on a very broad range: consumer, enterprise, and industrial. So if you look at the consumer segment, the first will be definitely AI PCs. It is right now pretty slow because of other technical issues of chipset, um, and the application software that required, and making the key use cases for the end consumer to decide what I will do with the AI, edge AI in my PC. So what are the use cases, what I can do? Because they are currently living in subscription to ChatGPT or some other apps. And when you have an edge AI PC, you can do it on your laptop. You don't have to do the subscription. You can run AI models. But the thing is, what are the use cases? How efficient it is, and those things are basically in the roadmap. But generally, it's the AI PC is one of them. The next, if you come to the more on the enterprise side, it will be coming on the thin edge, thick edge. It will also come into the I mean, consumer premises equipment, which is both for consumer, it's also for the enterprises. It's a network infrastructure device. It's the access point. You put AI in there, and all your sensor data come to the CPs, and you use it. Right now, FWA market is gaining a lot of traction, fixed wireless access, and most of the companies are trying to implement edge AI within the access point. And then in the industrial environment, what is happening is the sensor camera. I mean, machine vision, hands down, is the largest adoption use case in the in manufacturing industry. And predictive maintenance and machine vision, both of them. But in the machine vision scenario, the previously the AI models either run into the cloud or maybe in the thick edge or thin edge. However, now what is happening with edge AI adoption, you are seeing a lot of edge AI inferencing happening on the camera itself. The camera is becoming more smart and intelligent now to doing all these inferences. So this is the generally some of the key devices where we are seeing the early adoption. Obviously, gateway and thin edge are the major one in industrial manufacturing as well, because it's a hub for all the sensor nodes that you have in the factory floor. So those are the key devices that we are seeing in the market that are getting traction.
And I think it is important to categorize it in that manner and to recognize that AGI isn't just this one amorphous blob that will work across consumer and enterprise in the same way. And I think it was interesting. You started by saying it's important to differentiate edge AI from AI, which has been around for a very long time, and it's also important to differentiate the different types of edge computing. And I was wondering why you think that is.
There are multiple categorization that is important to differentiate. One is the use cases and the cost of the chipset that you're going to use. So let's say, for example, if you have a use case that is required a very low latency and your sensor data is generating and you want immediate calculation of or AI algorithm you want to run very closer to the sensor data generation, and you want immediate response, and it's not that big of AI model, it's a small AI model. So you need a not very high computing chipset. You need something that can do your job for that AI model. And your use case is very specific. You don't have to do multiple use cases from that the AI chipset or edge AI device. You have to do very one specific chipset use case. Now, in that scenario, it need to be micro edge. And in the micro edge, we also need to consider that it may be a battery powered device. It doesn't have to be always power connected. So my chipset need to be power efficient compared to on a thick edge where the power is not an issue. And in the micro edge, power is always an issue. Now, when we move to thin edge, the thin edge, you need a chipset that is capable of running multiple AI models, or at least have capability of running multiple data that is required for running an AI model inference. So there's a different chipset requirement. And again, in the thin edge part compared to micro edge, the power requirement is totally different because it will not be battery power. It will be a wired connected power, and hence you can have a much higher chipset capability to running at the thin edge. And in the thin edge, again, you can not only run multiple AI models, but multiple generative AI models now also coming into the edge because your thick edge has a more capability to run that. So all three levels have a different use case, different power requirement, different chipset requirement, and hence it is very important to have different categories. Not all companies want thin edge, or not all companies want micro edge. Depend upon the use case and their customers' requirement.
Mm-hmm. And of the different use cases you mentioned, I think you said the AI PC for consumer, you mentioned machine vision for industrial. Are there certain use cases that are more commercially viable than others in terms of they might be more, they might give the company using them more dividends than others?
I mean, yes, machine vision will be the one which will be mass commercialization will happen. But apart from these, I think there is another use case we have a mass commercialization, which is automotive. So automotive is also becoming an edge AI. When you talk about because your car is becoming not only smart intelligent because it's going to run ADAS function, it's going to run connected vehicle, and all the sensor data. If you send this into the cloud, um, it takes a huge bandwidth, network bandwidth. Who will pay for those bandwidth data? Because this all sensor data is not required for the end customer. Some of them useful for safety, some of them useful for OEM, some are useful for the operator. So it doesn't make any sense to send terabytes of data to the cloud every time you run a car, right? So it completely makes sense to have an edge AI inference within your vehicle. And this is something that we will see very quickly getting adopted, because vehicle is already getting packed up with lot of AI chipsets for other functions like sensor fusion for ADAS functions. So we will see a growing number of adoption in automotive as well, apart from these ones. So they will scale more.
Yeah, no, definitely. I think it's a good reflection of how we're still at a very early stage of adoption, and certainly there'll be new use cases, opportunities opened up. I think it's a really exciting time for edge AI adoption. Earlier, you were talking about, not just considering the use case, but considering the chipsets. The hardware is obviously a really important part of running AI models. One thing that's been suggested or said before is that hardware vendors and software vendors, there's some disparity in that hardware vendors don't necessarily have the software. It's not up to scratch. They're still sort of lagging behind. So I just wanted to know your thoughts on what you're seeing there between two companies, and whether maybe there are some companies who are doing quite well at offering both for edge AI.
That's a very good question, and it's very important for the edge AI, because whenever we someone talk about edge AI, they always think of hardware, chipset, and everything because it's about edge. But I think it is very important to talk about the how the software is getting integrated very tightly with the hardware, and that is very important for edge AI. And why I'm saying this is because you require not only AI models to inference at the edge, but also you have to help your developer to test those AI models before deploying the solution. You have to test those AI models for creating your application. So that's the one part of it. And then another part is the inference part when you do the inference. So you have to make sure. Then the one of the biggest part is training and retraining of the models. So let's say if you find an open source model, but it is not very accurate to your requirement and you want to fine tune it, how you want to do that? Where is the software requirement there to that? Can you do it on your own? Can you have to talk to some other clients to do that? So this is very, it was pretty much fragmented. Now, most of the few companies that I'm going to talk about, they quickly jumped on this problem and tried to solve this. And then Qualcomm is one of them. They created their own AI hub where you have the opportunity to take the models and fine tune it. And then they will give you an cloud space where you can test the models, to test the application. And once you think it is good, then you need to buy the hardware. Advantech is doing the same thing. Now, these are two different levels. One is a chipset company, one is the gateway or IPC company. Now, how this is two different is that now Advantech has a capability to opt the Qualcomm chipset and some of the function that they want Qualcomm it can take from Qualcomm, and then and Advantech is doing on their own, so it can doesn't have to rely always on Qualcomm, so it can move to different chipsets. So it becomes a chipset agnostic companies that it doesn't have to rely only one hardware because they are doing the software on their own. So what we call it edge AI stack. In this edge AI stack, what these companies are trying to do, who are also doing the hardware, is trying to create a software stack where they are providing the software to developers, to training for inferencing, and tightly couple it in a way that it becomes a very smooth process. Otherwise, it's a very difficult process some of the time, because maybe the model is in a trained in CUDA, and you don't have a NVIDIA chipset for inferencing. You have an Intel chipset for inferencing. So you need to run in OpenVINO. So that conversion from ONXS to OpenVINO, it sounds very simple for us, but for the end consumer, it's not. So for the developers, need to save time. They need some this kind of library where you can bring your own data, bring your own model, fine tune the model, and then test and then deploy. So some of the companies like Qualcomm is doing that, as I said. From a module perspective, Fibocom is doing that, Semcom is doing that. And then from vendor perspective, from manufacturing, Siemens is doing that. Beckhoff has a machine learning for machine vision, specifically a software. Advantech, as I said, doing that. Eurotech also have something on the software they're building, and they are on the stage of building a full AI stack. Some of the companies like Qualcomm have acquired Edge Impulse specifically for that, to strengthen their software capability for Edge AI. and which also includes training, inferencing, fine tuning, and all those things. So this clearly gives us a very clear trend in the market that it's not just about hardware, the coupling with software and hardware and deploying it as a solution rather than two different elements of the solution.
Mhm. Just out of interest, you mentioned Qualcomm's acquisition of Edge Impulse, which was, quite big news. Do you think it will become more common for large companies like Qualcomm to acquire smaller AI companies to get those capabilities in house? Do you see that becoming a more common trend? I suppose.
I mean, yes and no. Yes, in the collaboration is definitely will be there. We already saw collaboration between MediaTek and NVIDIA very clearly. So this the trend is collaboration, and it can happen through partnership. It can happen through acquisition, and that depends upon the both the companies where are they stands in the ecosystem, which company is bigger than who. But collaboration is the very clear trend that no, you cannot do everything on your own, and that's the very clear message. And hence, you need to collaborate with other companies, and it can be through partnership, it can be through joint venture, it can be through acquisition. So we are seeing this trend of more and more collaboration. We also see there are some of the acquisition trends as well. I can quickly talk about. One is Qualcomm acquiring Agent. One is not. I don't think it is finalized yet, but NXP is talking about acquiring Kinara for the 40 tops, and it is not just for software, but it's more also for hardware capabilities. So the trend expands more beyond the software, but it also from overall edge AI stack. If you talk about it expanding, so yes, we are seeing the trend, but I think the bigger trend is collaboration and not doing everything on your own.
Which I think is a really good point in the context of this still being a very new market. So we were just talking about the disparity between hardware and software vendors and a little bit about the companies who have been quite quick to embrace the full stack. Sorry. I was just curious if you've seen any other constraints or barriers that need to be addressed or overcome to encourage more edge AI growth.
I mean, one of the clear thing it is important to very clearly identify the issue right now, which happened in the IoT as well, that not every use case will be similar to each other. Everything will have a different requirement. If I say I am deploying machine vision and you are deploying machine vision, and let's say we are doing for the same factory, we are competitors, doesn't mean that your use case is similar to mine. My may have required of a different lightning, different temperature. I have, let's say my factory is in and like Germany. Yeah, so I don't have to focus on the temperature issue. But let's say my factory is in Middle East, I have to focus on the temperature issue because there's a different temperature there. So it's very minute details, but it's very important. So for example, lightning, my factory lightning is totally different than your factory lightning. So you need to make sure when you run that inferencing, you need to make sure that that has taken into account. I cannot use your AI model very clearly available and I run it on my factory just because we have the same use case. So environment and small details are very important. So that's the first step, to make it very clear that every use case is different and everything need to be customized, test, and then deploy. So accuracy is very important in these functions. One of the thing is also important with the agentic AI capability coming into the picture, which is still a distant, that makes sure human element is still there to make sure this process is not fully automatized. Because if you make it fully automated, you don't know where the error is happening. So it is right now is very important to keep the human element for now in the whole process. So yeah, these are the things I think which is very important right now to make sure that deployment. And obviously, the bigger challenge is the knowledge gap, skill gap. It's technologically we are growing, we know, but the knowledge and skill gap is making your own AI team investing on human elements in the edge AI. So make your team capable of running an edge AI, not replacing them with your edge AI. So I think that is very important right now.
So, sort of like that famous saying, "Don't run before you can walk." I think applies well.
Exactly. I think right the time it is the time to do it very carefully. Then you can in future you can do it in automate that.
Sure. So, another thing worth mentioning, and for those listening, I attended a talk of Satya's back in June, which was talking about trends in Edge AI. And one thing that you flagged that I thought would be interesting for us to talk a little bit more here on the podcast was Edge AI transitioning from tiny ML to multimodal VLMs. Sorry, that's not the easiest to say. So could you talk a little bit about what that transition looks like and what the impacts will be?
Yeah, I mean, if you look at the traditional AGI, was generally limited to the tiny ML models. As I said, because the chipset were capable of running models which is hardly 1 KB or 4 KB max, 4 kilobytes. And that is basically the tiny machine learning. And we had an organization called Tiny ML. And this transition happened, and one of the key proof point for that is was that that organization changed its own name from TinyML to Edge Foundation, AGI Foundation. And why it is happening? Because now the price of per compute is going down, and the computation of per chipset is going up. So what is happening they are both getting inversely proportional. So you have more and more capability of running inference model in your edge. But at the same time, it is also what is happening. Your AI models is shrinking. The AI models, which has capable of doing, let's say, 100x with 3 billion parameter, you can do that right now, the 100x, let's say 1 billion parameter. So your AI model is shrinking, but your efficiency of those AI models is increasing. With these two scenarios coming into the picture, it completely makes sense that edge is getting a lot of traction. Now, what is happening is that now earlier you have only CPU or from ARM base, and then you have, and now NPU is coming into the picture or with ARM, let's say Ethos NPU. And what is happening is bringing the capability of your tiny ML to slightly more than tiny. And then you have a capability of bringing CPU or plus NPU or integrated GPU, let's say from Qualcomm, and then you're bringing that capability of TinyML to slightly higher. Let's say you are inferencing 1 TOPS, and then from 1 TOPS you are now 40 TOPS because Qualcomm is bringing that capability. And then you have discrete GPUs from like NVIDIA Jetson that bringing that 40 TOPS capability, matching that 40 TOPS capability. And then you have PCI slot cards for thick edge. You have Qualcomm A100 NPU based PCI slot cards for in-house edge processing, having capability of 278 TOPS or so. Um, which makes it very clear that my hardware is not just capable of running any 4 KB models, it has capable running of billions of parameters now. So the range of edge AI has have expanded from tiny ML to not only one language model, but multiple language model. And not only multiple language model, multiple modality model. So it's not about just about language anymore. It's about vision, it's about audio, it's about text, which was already there. So it's not only one modality, it's multiple modality model. So that's how the range has expanded from just tiny ML to multiple modality vision language models or language models.
Do you, following on from that, do you think there's still a place for TinyML in the market?
For sure, it is there because I mean, if you look at the IoT market, the NB-IoT and LTM market is having 37% of market share right now. Yeah, more than that. And this set of devices is very low end, low powered, very low computing required. You don't need to compute every day. You need to compute once in a week, let's say. And generally what they're doing is sending data to, let's say, once in a week, right? And if you bring those AI models just to send not the whole set of data of 1 week, just the outcome of that one data, what happened in 1 week, let's say smart meters. In smart meters, right now, smart meter is sending, let's say once a week, what happened this week, and it's sending in bytes, kilobytes, or bytes. If you bring that AI model just to categorize the how many times your power was on, not, so basically summarizing your raw data and just send one information that is required to send for billing, for analysis, and just only send one data. It not only saves the operating cost on the or connectivity, which was already low, but also makes your device capable of doing this computation and not relying on the network always. So I think there's a still a room for tiny ML, and the only thing is that you have to make sure make see that how you can make the use cases of it and how you deploy it. But I definitely see that a lot of IoT devices, even coming right now, may require tiny ML as well.
And ultimately, I think going back to this point you're making about just the market expanding and the different technologies available expanding, will ultimately it would just benefit the end users and those operating the machinery and everything imaginable. So I think that's great. I appreciate this was very much a whistle-stop tour of the Edge AI market, and we probably could talk about it for a while. But at the risk of going on, Satya, I just wanted to know if there was anything else you wanted to mention to those listening that you think is important before we wrap up.
I mean, one of the important thing is that I think nobody's talking about it is security, and why it is important. Even edge AI is more secure than your compared to the data is going out of your edge. It is secure because data is still in your edge, but it is important because um, when you are retraining your data models with your data, you need to make sure that that model is not going to anyone else. So you need to make sure that that model is being used for you, because if you are retrained with your own data, it need to be with you. So I think with Gen AI, with Edge AI that is happening right now, and there is one important discussion is about the security. And when you have a lot of, let's say, Edge AI with have a Gen AI capability and writing prompt, you need to make sure that prompt are not the way to hack into my own device, right? So I think those things are not in the discussion in the right now, and I think we need to come into a discussion, come into the front page of discussion to talk about how what are the implication of these, what are the security risk, how it is impact the post quantum security that is coming anyway, is it had any impact on that? I think those questions are very important to discuss, security as a whole and edge AI security as well.
Sure. Well, I hope there are definitely some things that those listening will take away from them. But in the meantime, thank you so much for joining me and for having the conversation. I really appreciate it.
Thank you. Thank you so much.
IoT Unplugged,